attempt or process, we can say, to eliminate or to minimize the problems occur due to the data redundancy over the lifetime of the database. So this is the key point we need to keep in mind while doing the normalization or simplification. You need to, or you will try to eliminate those tuples or those records which are having the duplicacy. But if we have the duplicate record, but how we can identify the record make have the multiple value? It also possible, but there should be one attribute that distinguish your record by the duplicacy pattern. So definitely a key attribute is required. So normalization will tell all such things. So it is also a good process, good attempt for finding the good database design using decomposition. So this is an important point we need to keep in mind while applying the normalization. And we have already discussed so many times about the good database, bad database. Okay, so what is mean by the good database? Bad database means a better database which can have the many records, many tuples, and form the duplicacy or inconsistency of codes. But we're talking about the good database, so it provides the uniqueness in its relation to tables. So this is a point from which point, from this point we can start the normalization. Yes, we have also some example by which we can understand the various kind of the normalization form. And from the very beginning part of the understanding normalization, I have already shared my important slide in which written there first normal form, second normal form, third normal form, or fourth and fifth normal form. So first, second, third, fourth, fifth, these are the five different normal form we have. And beside of these normal form, we have the BCNF, and we have also multi-valued normal form, and that last one we have the PZNF. So beside of these different normal form, we have the three important normal form. Those are the multi-valued, PZNF, and BCNF. Here I want to tell you very true fact about the normalization. Then you can understand first normal form, second normal form, third normal form, and BCNF you can implement at student level, and you can also implement the multi-valued. But when looking for the important part that is related to your large project, then it is not easy to implement the PCNF or fifth normal form in your table. So that is an important point we need to keep in mind. So suppose you are creating a project, developing a project in your BTech degree, then hardly but true, it is true fact, hardly you can simplify or normalize your table by third normal form or BCNF, and that is enough. So most of the cases when looking for any table that could be simplified or normalized up to the BCNF maximum. So fourth NF and PCNF, it is not easy to implement and it is not easy to apply in your table, because it takes it will reduce a much complexity and it provides the simplification in simple way, but it is not easy to apply. Okay, now it is clear to all. It is clear to all.
Yes, sir.
Sir.
Yes, sir. Clear.
Yes, any doubt so far what is mean by the normalization? I have already discussed. Just please tell me.
No, sir.
Okay.
Sir, will you discuss types of normalization after this?
Yes, of course, of course. Diagram, which diagram?
Sir, types of normalization, sir.
Yes, of
Title.
course. Yes, of course, my dear. Normalization I'm starting, so I will describe normalization types one by one with help of the example. Then you can understand.
Okay, sir. Okay.
And we will see the some important terms. Those are decomposition, functional dependency. Then we have already discussed all these points previously, so it will help, so all those terms will help to understand the this concept in simplify. So just I'm sharing the my first slide, then you can see we are starting or we are looking for the first normal form. So what is mean by the first normal form? Then you can read the three important points. This is also known as a flat file. Okay, and it is also shown in form the first normal form. This statement is saying to us what the database, what the relation we have that is by default is in into the first normal form. So what the information we have, just like see, if you remember the student relation, name, course, phone number, major, professor, grade. If you remember that this table or this relation at the time of the understanding about the normalization word, or before starting the functional dependency, we have seen this student relation, and by default this relation is in first normal form. Now see. So this is the first point we need to keep in mind. So the table, the relation we have, that can have the duplicacy record, no problem, it can have. So that is known as the first normal form. And there is no composite attribute and no describe one property, and okay, and only the one property will be described, that is only the keep the information only, nothing else, and no composite attribute we have over here. And the database scheme or database which is known, or table which is known as is first NF, that is a first normal form. If every relation is scheme, if every relation is scheme, or we can say schema, okay, if every relation is schema included in the database schema is in the first normal form. So the table, the relation we have by default, which is a part of the our database, definitely we can say it is a first normal form. Here I mean to say that over here, that you can say, just let me explain by the example, then you can understand in more simplification. I'm just taking this example, then you can understand. I have the student relation, okay. Now I have the faculty relation. Now this is a student relation, and this faculty relation are related to each other by providing the some relationship. So this is a relation, this is a relation, and this relation, student relation or faculty relation, it can have the multiple copy, no uniqueness. And but all these two relations are the part of the our university database. Suppose it is a part of the university database. So by default the relation, those are known as the student relation and faculty relation. By default this is part of the first normal form. And now see, if the relation is a table which is not a part of the any relational table or relational information, then by default it is also would be the in form of the first normal form. So that's why we can say, if a table which is already in form of the relational information, not non-relational information, but that is in form of the first normal form. And from this point we will start the level by level, that is the second, third and fourth and so on. So here you need to keep in mind that there are no composite attributes and describes only the one property, that is a, it is a part of the database. And so we can say the first normal form. So can we say this relation is in first normal form? Of course, student relation by default is a part of the first normal form. So this is clear to all. Now from the definition part, if you have any doubt, please let me know, you can ask me from this point, please tell me.
No, sir.
Okay, so okay, so now this is a relation which is in the first normal form. The normalization will start from the actual normalization will start from the second normal form. So second normal form will take much time to understand the normalization process. So you have to keep in mind the important point, that is we have the our second normal form is a normal form that is should be in form of the first normal form. And the word we need to keep in mind, non-key attributes are fully functionally dependent on the key attributes. This is the key point we need to keep in mind. So that's why I'm just putting the star over here. This is the actual point from which we can understand the second normal form is saying to us it should be in the first normal form, or it means it should means a relational or the table should be in form of the first normal form. And non-key attributes are fully functionally dependent on the key attributes. It means the key attribute, suppose we have the is, or we have the address. Suppose we have the other attribute which are non-key attribute are our depend on the our key attributes. Here I'm
Yeah.
not talking yes, I'm not talking about the any primary key or any other key right now. You have to keep in mind the point. I'm not talking about here primary key or foreign key. The word we need to keep in mind, key attribute, and this key attribute could be any form like super key or candidate key, so there is no issue. If you remember this diagram, dependency diagram, if you remember, I hope so you remember. So phone number and measure are depend on the name. So what happened? Name for this phone and measure are the part of the measure is the dependent measure in the measure determine the phone and name is determined by the phone and measure. So what does it mean? This is what, this is the non-key attribute are dependent on the key attribute. But can we say a name would be the part of the key attribute? If there will be only one case, if name all the value which are part of the name attribute, if we have the uniqueness, so we can say at that time. So here we need to keep in mind the proper definition. A relation or table is set to be in second normal form, that should be in the first normal form. And non-key attributes are fully functionally dependent on the key attribute. From this point you can understand, if I'm talking about the fully functional dependent, so okay, this concept we have already seen, so now you can understand the normalization. And second point we need to keep in mind, if the key has more than one attribute, okay, so if we have the key has a more than one attribute, then no known key, okay, no known key attributes should be fully functionally dependent on a part of the key attribute. So this is the point we need to keep in mind. Suppose we have the more than one key attributes, at the time no known key attribute should be fully functionally dependent on the part of the key attributes. Now why? Because then there is only the one key attribute, so it's okay, we can say. But we have the more than one attributes, key attributes, then at the time we need to determine then which non-key attribute that is to be dependent on the such attribute. So at the time you need to take care of the all those points. So doing the normalization you need to define uh, in the specific way. And normalization process and FD or functional dependency is a process where you have to use logic or brain to find or to simplify the information. So it's to depend on the user functionality, but you need to take care of the all these points. The things we have, the definition should be proper. So in the definition is saying to us the normalization, in the second normalization, non-key attributes are fully functionally dependent on the key attribute. But the key point we have over here, if the key has more than one attribute, or the key has the more than one attributes, means here key may have the multi-valued attribute. At the time how you can define, so the point is written over here, if the key has the more than one attribute, then non-key attribute should be should no non-key attribute should be functionally dependent. So this is a point we need to keep in mind. But now how we can say the key can have the one attribute like address. So if you're dividing the address is our key attribute, suppose that, so address is divided into the three different sub attributes. So here the multi-valued attribute you are talking, so the definition of the second normal form may violent at such time. So this is the second point we need to keep in mind while applying the our second normal form on the relation. So here I'm just sharing this ppt or this slide. You can see dependency, we know that is name, that is determinant to the phone and measure. So phone and measure are the two attributes which are depend on the name. Now grid is an attribute which is dependent on the name and course. So you can see the diagram carefully. From this point you can observe professor is depend on the course, major and phone is depend on the name. But while grade is an attribute which is depend on the name and course, so at the time the grade is depend on the composite attributes, and those are the name and course. So this diagram you need to take care in your mind properly. Now see, so dependency diagram is saying to us this leads data redundancy and anomalies. If you remember the word, various kind of anomalies: insertion, deletion, updation. So while applying such kind of dependency, we try to apply any kind of the insertion, deletion, or updation. So anomalies may occur anytime. So this is a problem. From this point, we need to normalize our data. So by default, table or relation will be the one normal form. There's no issue. But when talking about the second normal form, then we need to take care of the all those points. That is a the known key attribute should be or fully functionally depend on the key attribute. So from this relation we need to find the key attribute. So from this point we will start, or we are going to identify the key attributes, and which attribute can be a key attribute, or is any other different attributes required to distinguish in our table or in our tuples or rows. So Just I'm just coming back to the my definition part. So let me know. The definition part is clear to all. This is the second normal form. The definition part is clear to all.
Yes, sir.
Okay, so since you are looking for the third normal form, so third normal form is saying to us that your relation must be, or your information or the table must be informed with the you in the second normal form, then you will apply the third normal form. So while applying the second normal form, that is table must be in the one normal form. If you're applying the second normal form, one normal form is required. If you're applying the third normal form, then it should be in the second normal form. Same thing, if you're looking for the fifth normal form, it means your information that should be, or the table must be informed with the fourth normal form, then you can apply the fifth normal form. We can't apply directly fifth normal form or fourth normal form without applying the second normal form, third normal form on the our relation. So this is a point we need to keep in mind. So this leads the data redundancy and anomalies. So of course we need to take care of this point. Now this can be solved by the means of the decomposition. So here how we can see. Now see, I'm just going to back to the explain the part. Name, course, phone number, major, professor, grade, these are the attributes. Okay, so this is a part of the our relation. Now, if I'm just putting the details, so there may be some chance where the duplicacy may occur into a table. Or yes, this is the part you can see now. From this relation, you can see Rohit, okay, Martin, name are in the duplicacy. Okay, course is also in form of duplicacy. Major also having duplicacy. Professor also, grade B also. So redundancy, of course, is occurring over here. So now, so we will try to decompose our relation into two different part. So let us understand this concept through the decomposition process, and what is mean by decomposition we have seen. So now see, this is a first we can decompose. So from the student relation we can take a we can decompose our relation into two different or through a three different factor or relations or table. So first can be identify the name, phone and major, because phone and major attributes are depend on the name. Okay, so this can be one relation. Can you say, can you agree with me? Because phone and major depend on the name. So can we say we are if we are decomposing? So can we say
Yes, sir, we can.
okay? So because it is found over here, phone and major depend on the name. Grade is depend on the name and course, and professor is depend on the course. So it is better idea that we can decompose. So after applying the decompose, at least we can avoid the redundancy. So let us check this process by the applying the decomposition process. So phone and major and name can be a part of the one relation. Next, professor and course will be the part of the one relation. Next we can make the name, course and grade, so we can have the three different relation. Can we say, we can have? Yes, please tell me.
Yes, sir.
Okay, so student relation in second normal form we can do, so there is no problem. So student information, name, phone number, measure. So we have the student information. So there is a one relation which is showing over here, student information, and it contains name, phone, and measure. And next we have the relation. From all these relations are coming from the student information, and here we have the name, course and grade. Next we have the ct. Okay, ct means course and teacher, so it is given over here the one relation, course and professor. So after decomposition, what we are doing, we are applying the decomposition, and after applying the decomposition it is found that non-key attributes are depend on the key attributes. Now see, is it applicable over here? Can we say is it applicable over here? Non-key attributes are depend on the key attributes. Can we say?
Yes, sir.
So how you can say?
Sir, because like if we sir, if we see student info, sir, name, phone, and major. So, sir, if
Okay.
we have name or student ID, sir, that can be key attribute, and rest become non-key attribute. So in this way, non-key attribute depend on the key attribute.
Uh, no. Okay, but just use only the given attributes. Don't add the another attributes. Okay. So now tell me, from this relation, name, phone number, measure, which one is a key attribute or which one is a non-key attributes?
Sir, I think here name is the key attribute, and phone and major are the non-key attribute.
Yes. And but name could be the same.
Sorry, sir.
Name could be the same. Rohit, or Martin into our relation. If you are taking the data,
Yes, sir. This can be same, but we have to reduce this thing, data redundancy.
since uh, since name is a main attribute, so because if looking for this point, phone number is now this is the point you need to keep in mind. That's why I'm just focusing on name is depend on the phone, because if this name student the information does not exist, then what is sense of having the phone? And this measure also depend on the name. So name becomes a key attribute, but this key attribute that can have the duplicates, there is no issue. But provided the uniqueness, and we can say in our relation by the phone number and measure we can have. And now see, if just let me explain by this concept by an example, then you can understand. Now see, I'm taking Rohit examples right now. Just give me 1 second. Yes, I'm taking Rohit. Just please keep in mind this simple word Rohit is a part of the name. And how many times Rohit we have? Rohit. Now
Uh,
for
Three times.
for yes, just yes, 3 times if you have. And now see, every times his entry, name, phone number are meeting or putting the same information. Now see, what is the other factor we have? Name, phone number, and last one is a measure. Now see, since phone and measure are depend on the name, so name becomes a key attribute. So at the time if I'm decomposing, so then what will I will get? I will get the Rohit information in the form of the name and phone number, that is I will get the 696453, and measure will be the computer. So there will be only the one entry into the our student info relation, that is after decomposing. Now see, yes. So there will be only the one entry instead of the, there will be only the one tuple or one row instead of the three, instead of the three tuples. So we are avoiding the duplicacy. Yes, please let me know. Yes, by this factoring or by applying, can we say we are getting the one record, or we are avoiding duplicacy?
Yes, sir.
Okay. So yes, yes. Since after applying the decomposition, after applying the decomposition, uh, we have the name, phone, and measure. Since phone and measure are the two attributes which are depend on the name. Why? Of course, if we don't have the student name in our relation, and what is the sense of having the phone and measure information? There is no sense. So these are the two attributes which are depend on the name attributes. So at the time name becomes a key attribute, we can say. Okay. So in our relation we have the name and phone and measure after decomposition or after applying this process. If you remember this point, after applying this process we have the name, phone, and measure in our one relation after decomposition. So we got the this table student info only. Now if you're looking for the data from student info relation, and it contain name, phone number, and measure attributes. Now, from this name, I found the Rohit. Rohit coming the 3 times. One, two, three. Just see. One, two, and 3 times. Rohit information coming. No issue. Phone number, he has a 696453. Every time he has the same phone number. Of course, student phone number will not be changed. Okay, we have the multiple entries. There is no issue. So, but we have the same kind of information. And Rohit opted the major subject, that is the computer science. So we have this point. So student from student relation, how many entries will be there? Three entries will be there. But if you are putting the three entries, Rohit is 696453 computer, and then Rohit is 696453, and so and so. Rohit is 696453. So three times you will do. So you are putting the redundancy. So avoid the redundancy. What we have done? We have done the decompose, and after decomposing, instead of the three tuples, we will have only the one tuple. We will have the one tuple, and to avoid the duplicacy, if we have the three tuples, then you have the duplicacy. Okay, you have the duplicacy. So why you are putting the duplicacy? And after decomposer, we got the second relation, that is the result. So in the result, you can say name, course, and grade. Okay, let us check this information once again. What are the things we have? Result, name, course, and grade. Name, course, and grade. So I'm just backing to the my slide. Just let me check the different, choose a different color. So yes, this one. We have the name, course, and what was the other thing for the result? Grade. Can we say?
Yes, sir.
What was the point? Name, just name, course, and grade. Okay. So name, course, and grade.
And
Yes.
major, sir.
Uh, 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 s- uh, Name. Just focus on the result relation right now. Name, course, and grade. See, Rohit, who have opted the course, Rohit, who have the courses the CS203, and he got the grade A. So this is the one relation. Oh, so one tuple. And next Nath CS303. This is the second. Okay, this is second. And next we have the Rohit again. But he has the different course CS328, and we have the B. So this is again third. Now Martin, who have the different, okay, so he got the grade A, so this would be the fourth one. Now Martin, who have the different course, so that is in progress of 5. And Rohit, who have the different course other than the 2 CS203 and CS 328, so he has the uh, in progress grade, so 6. So after seeing all these things, we have the 7 different tuples. Now every time is what you can just note down important point. Course is depend on the name, and grade is depend on the name. But grade is depend on the name. Can we say grade is depend on the name?
Yes, sir.
No, no. Grade is depend on the name and course. Okay. So if you need to find the grade of any student, then what you are required, you need the name. So name is not a single things which cannot be, sorry, grade is not a single thing which cannot be depend on the name only. Just like you, the Harshit or Shivam, Mayank, or any other student, say XYZ student. So name of the expired student can be many times, but what he or she has opted, so along with his course we can find, or we can finalize the course. So this is a point. So by applying the composite attribute we can do, so this is a point we need to keep in mind, and that is the second point we need to clear. If the key has a more than one attribute, then no attribute should be fully functional depend on the part of the key attribute. So here in this point, what is the non-key attribute? That is a grade. So this grade attribute is depend on the name and course, because here we are looking for the key attribute in form of the composite key attribute, we can say. So definitely at the time you need to focus this important point. Now see, so here we will got the, or we will, sorry, we will get 7 different tuples. Just let me come to the point. Here we will get the 7 different tuples, and no duplicacy of course will be agree. And name and course is known as over here composite key attributes. Composite key attribute. Composite key attributes. Now, and how you can say the grade can be a key attribute? No, it will be always non-key attribute. Why? Grade maybe it is a good class or in which all student got grade A, and C. No student got the no one student got the B on C or the grade. Only every student got each and every student got the A grade. Then we have the multiple copy or duplicacy. So definitely it could be the non-key attributes. So grade is depend on the name and course. So we have done this activity like this diagram. You have remembered. So after applying all these things, it is found that we got the 7 different tuples, and it determined that each and every student followed by the course having the his or her grade. So this is the point. Now next relation we have the after decomposition, that is a course and teacher, so course and professor. Now let us check this table also. Just I'm just back to the my point, course and professor. Yes. So from this point you can see if there is duplicacy, then we will try to avoid such part. Now course CS203, CS203, which is offered by the professor Razar. CS303 is which is offered by the Bharat professor. Okay, so we can say this is like this one, there is no issue. And CS303 we have offered by the professor Bharat, and CS302 328, which is offered by the professor Razat. Okay, so Professor Razat offered two different courses, that is CS20203 and 328. Now, here we have the duplicacy record CS303 and Bharat. So we will not pick this one. So we will pick the this tuple and this tuple and this tuple. And CS503 is provided by the or offered by the Siam professor. So we will also pick this tuple, and of course cross is another professor who have providing this one. And same thing last we full found this part. So now there is only the one tuple which is having a redundancy. So from this point after decomposition, if we try to select the all the professor who are offering the course, definitely among these 7 tuples we will see only the 6, because we will try to avoid the duplicacy. So from this point, from this relation, 1 2 3 4 5 6, so how many tuples or rows will be displayed by this relation? That is a 6 tuples, and this is all these tuples having the uniqueness, no duplicacy. So after decomposition, followed by the second NF, what we are looking for, we are seeing that what we are seeing that each and every relation, that is we can say the sub relation after decompose from the main relation, no relation have the duplicacy. So from first NF to second NF, what we are saying, we are removing the duplicacy, we are eliminating the duplicacy. So this is a point. So is it clear to all right now? Please tell me with this example.
Yes, sir, clear. But sir, can you tell us like for the CT 6 tuples, for the result 7 tuples, sir, which 7, which 6?
Okay, now see, my dear student, professor is depend on the course. So at the time that the course becomes the key attributes. Okay, so this course become the key attribute, and professors are non-key attributes, because a professor can offer the multiple courses just like me. So I'm offering the Python, that is a CS1021. I'm also offering the DBMS CS 1053, something like that. Okay, so this is a course, two different courses I'm offering, and I'm only the one professor. So at the time what happened, there will be two entries into the my relation CS1021 P, that is Python, and CS 1053, and that is a DBMS. Okay, so two different courses I'm offering, but who is offering? Only the one professor, that is Birensi. So at the time what I you can see,
Sir,
my entry, my information depend on the course what I'm offering. So at the time the course information or course detail will be as a key attribute. Yes, now tell me.
Sir, but a course also can be offered by multiple professors also, no?
Yes, of course, of course, of course. So at the time, suppose CS1021 is also offering by the X professor and by professor. So at the time, you can see the B, if we need to look at the tuples or row. So this is a course which is offered by the B, and this course is also offered by the X, and this course offered by the Y. So every time the entry or record will be distinguished. So whenever I need to check who have offered this course, so I will found the three different professor names, that is B, X, and Y. So definitely we can say no problem. But course is an attribute which distinguish your this part who have offered this course, so by which I can distinguish. But as a teacher or as a faculty, I'm offering the multiple courses, so definitely I can't offer the two times the same course, like CS2 1021 offered by the B, and CS2 1021 by offered by uh, another person, that is only me, so V. So it just provide a duplicacy. Now see just this point. uh just give me 1 second, just see. See, Rohit, who is opted the course CS203, which is offered by the Professor Rajat. Now, okay, and now Martin, who is selected or opted the course CS303, okay, and which is offered by the Bharat. And now see, Nath is a student who have opted the CS303 and which is offered by the Bharat. So in our relation, which is having by the only the two different attributes, those are the course and professor. So from this point you can see, if you try to put all the details 7 times you can do. But why are putting this entry CS303 which is offered by the Professor Bharat? Because it this entry is already done over here, so why are putting another time? So it provided duplicacy. To avoid duplicacy, we are decomposed, and after decompose, we found the two different attributes. Those are the course and professor. And from this point, we can justify we are avoiding duplicacy, because this is the point where we can find the professor offering the many courses or professor offering the single courses. No problem. Yes, instead of the CS303, if we have instead of the CS303, suppose we have the another course like CS504, something like I'm taking this again. So at the time the 7 tuples will be there, because this is a different course, and which is offered by the Bharat previously, that was the CS303. So right now the Bharat professor is offering the CS504, so that's why we can say this entry will be applicable. But this is old course which is already offered by the, or which is already entered by us previously. So there's no required to put into the our relation, so that's why we are avoiding the duplicacy. So instead of taking the 7 tuples, we are taking only the 6 tuples right now, and the relation will show only the 6 tuples. Yes, from this
Okay, sir.
point now tell me. Okay,
Yes, sir.
good.
Now clear, sir. But another one is also, sir, where you said this has seven tuples.
No, just I've written my idea, just see.
Sir, have you written
The,
out of seven?
out of 7 we will see, or this CT relation will provide only the 6 tuples. So I have just mark over here the 7 tuples will be there.
Sir, in this result part, sir, seven tuples.
7 tuples will be represented by the result. Now see, you can see over, because every student have a student opted the multiple courses, and which is offered by the many faculty, that mean, and every student have the different grade in his opted course. So definitely at that time, now you are C, so you are the X student, so you have opted the 5 different courses, but student name will be the same, but your uh, course ID or course number will be the different. So it doesn't mean who is a professor, who is faculty at the time. Maybe the professor who is associated with you, maybe duplicacy, like you have opted a course which is offered by the uh, uh, a single person or single faculty 2 times, and you have chosen same faculty by the different course ID. So at the time your name will be same, the faculty name will be same, but how you can distinguish only the based on the course. So at the time course become the key attributes. So in the CT relation it is found that the course is a key attribute and professor is a non-key attribute. It is depend on the course. So professor and professor depend on the course what he is about. So this was my point. If I'm displaying all the details, so only six information from the R student information table will be displayed by only the six tuples only. It will not display the seven. It will display the seven. It means there will be the one duplicacy record. So there is no sense.
Sir, for result, what will be the key attribute? Name or course?
Yes, which one? Result.
Yes, sir. Result relation.
In the result relation, there will be the three different attribute to be displayed: name, course, and grade. So now see, you can see if I'm just displaying
No, sir. Sir,
name,
actually, I am asking key attribute. Which one out of these three?
key attribute will be the name and course. That is composite key attribute. See,
Uh,
grade can be the duplicacy. There is no issue. So it can't be the non-key attribute. Like you are the X student, and you have chosen the 1, 2, 3 course, and you got the grade A. You are the X student, and you have opted the another course like 4, 5, 6, and you also got the grade A the same. So this can have the duplicacy. So this grade can't be no this can't be key attribute. This will be the non-key attribute. Okay, and now your this enter your name along with the your course, that can be the composite attribute to distinguish your selected course. So now see, if I need to check which course you have selected, so 1, 2, 3 and 4, 5, 6 opted by the X student. So there can be the multiple entries like y y is a student, y 1, 2, 3 a. Okay, and by 4, 5, 6 a. So at the time it is easily to found that only the name and course that carries the composite attribute that can be defined that it is a key composite attribute. So in this result relation it is noted down that course and name can't be key attributes. Why? Because multiple entry will be there. Now
yes.
course can be the multiple times like 1, 2, 3. 1, 2, 3 is again for the Y student and Z student and W student. Okay, so by the making the composition of these two attribute, we can say the key composite attribute can be the composite way. So this is a point we need to keep in mind.
So, sir, we are taking pair of name and course as
Yes,
key
of course,
attribute.
of course. In the
Okay.
functional dependency manner, you can write like this manner: name, comma course. Okay, that is determinant to grade. So we can say grade of any student is depend on the his name or her name and the course what he or she is obtained. There is a pattern which is written into the functional dependency manner. Now it is clear
Okay.
to you.
Yes, sir. Understood.
Okay, good. So this is the part which is coming from the decompositions. Now let me show you the another part. So by combining these three relations using the common attributes, we will get the original relations. So in this relation, if we are applying the join operation, if we apply the join operation, now what is the thing you are looking for here? Here you need to see the important part, that is you can observe over here. Now this relation contain the one tuple, this relation contain the seven tuple, and this relation contain the six tuples. Now tell me from which tables or which relation I should apply the join operation to get the original data. Yes, please tell me. Student relation, on what?
Result relation.
So since you can see student information and result we have. So first we will apply the join operation between the student information and student information and a result. So you can see over here on what parameter or what is a common attribute which is having by the result and student information, that is a name. Okay, so based on the name attribute, we can apply the join operation, and after applying the join operation, we will get something relation, and some relation is known as a xyz. I am taking the this example. So this relation will be generated by the student info and result relation joining operation, or we can say joining operation between the student info relation and result information. So we will get a relation that is known as the xyz. And in this xyz, what would be the attributes? Of course, name, phone number, and major. Why? Because student information will be on the left side. So the attributes of the student information will be displayed first, and then course, and then a grade. So five different attributes which would be the part of the xyz, or we can say the newly generated relation after applying the joining operation between the student info and result. And now then you will make the joining between this xyz and ct. So what is the common factor or common attribute? You can see there's a course, and here the course. So from this point you can apply the join operation, and you can understand when you try to apply the join operation, then you are required to put a condition. And of course, what would be the condition? Result or course, we will take only those course, we will take only those course, or those name who are belong to the same parameter. So definitely from that point, we will get the original table, and the table will be look like this one, or our original table. So after applying the joining operation, we will get the same data. So at that time we can say we are not losing any information. So we have the lossless, we done the, or we did the lossless decomposition. And suppose we are losing some information, then we can say we did the decomposition, which was a part of the lossy. So here the point which is written over here, by combining these three relations using common attributes, we will get the original relation. So we will get the original relation. It means we did, or we have done the lossless decomposition. Yes. Now tell me, this point is clear to you right now?
Yes, sir.
Okay, good. So now, here we have the summarized information with the diagrammatic way, and it will help you to understand the concept properly in more detail. The student information, what we have the name, phone, and major. So from this point we have done. So name to phone dependency and name to major dependency are being preserved in the student info relation. Now see. So here we have the description of the work what we have done over here. The student info relation which determine that is the name and major information will be preserved by the name into a single relation. Okay, into a single relation we have seen like the Rohit. Okay, so only the one information to be displayed by only the Rohit. Now we have the next student. Next student is the Nath. Next student we have the
Sir,
Martin.
I have a doubt. Hello, sir.
Yes, please tell me.
Sir, we have made these three relations from the main table. Sir,
Yes, sir.
can this number of tables will be differ? Like I got three tables,
Yeah,
someone got
yeah,
four tables.
yes, of course. It could be many table, but at the time, after applying the decomposition, you need to take care of all those point. If we after if we try to compose, then uh, we should not lose information. If you're losing some information, then there is no sense for applying the decomposition. Like you are taking the result. Okay, from this result part, you are taking only the name and grade. You are not taking the course. Okay, because name is part of the student, so we can make it. But how you can make it? So after the applying the, or after doing the normalization, you need to take care of all those points, and there is no algorithmic rule, no specific rule is available here. And you have to use your brain, or you have to use a logic or idea to apply the uh, normalization. But keep in mind, the non-key attribute should be functionally dependent on the key attributes. This is the key point we need to keep in mind applying the while applying the normalization into the second normal form. So this is the point. So you can have the multiple column there instead of the three tables. You can have the multiple column, but keep in mind, if we try to join all these relation, then make sure you will get the same or original result or original table. You can do, there is no issue here. By the our relation we will get only the three relation into the, maybe you can have only two relations, maybe you can have the two relation. So there is no,
Yes.
there is no specific rule, only we will have the two or three relation. Depends on the your requirement, depend on your decomposition process, you can have the n number of the relation, sorry, n number of the relation from a relation. So there is no issue, you can have. Okay, so this was the point. So okay, now shall I continue?
Yes, sir. Yes, sir. Sure.
Okay, good. So name to font dependency and name to mirror dependency are being preserved in the student information, of course. So from this point, you can say we are getting the three tuples which are belong to the Rohit and his phone number and his opted course like computer science. So instead of putting the three information or three tuples, we will take only the one tuple. So we are avoiding the redundancy. So definitely it will preserve, and we will try to join definitely it after applying the join operation. We will get the again multiple entry along with the course and grade and professor definitely. So it will preserve the information. So this is the point we need to keep in mind. Same thing we will also apply it over here. So course to professor, okay, the course to professor, it means course determinant to the professor is being preserved in the ct relation. So here we have the point. So the preservation is saying to us, if you're doing the functional dependency, or if you try to say over here in a second normal form, a non-key attribute is fully functionally dependent on the key attribute. It means if you're trying to get the original information after decomposition, then functional dependency is as it is preserved. So at the time what we have, that is known as a preserving functional dependency. The functional dependency should be like this one, your information should be preserved as it is, no information should be lost. If you are losing some information, that you are having the non sorry, lossy decomposition. And keep in mind a relation that you are looking for the loss purpose or a lossy manner, then what is sense of such concept? There is no sense. So decomposition can be lossy, but keep in mind what kind of the information we are doing. Now just yes, from this point, suppose I am taking the name only here, or I am taking only the grade only, I am taking only the professor only in the city relation, I am not having the another common attribute. So if I try to merge, if I try to combine such relation or decompose relation along with the another relation or by applying the join operation, I will not get the original data. I will not get the original table at that time. What I'm doing, I'm applying the lossy decomposition. I may lose my information. So I'm not preserving the dependency. I'm not preserving the such information. So here, these diagram are describing this concept. Now see, same thing. And now name and course are related to being preserved in the result relation. So this is the point. So we finally we got the three different relation after
Sir,
applying
can
the
we
normalization.
implement this in the next lecture?
Uh, yes, not next lecture. After midterm, I will tell you the how to apply the practical way. I will tell you how to apply the first normal form, second normal form on the such relation. So of course we will try to create a table the same this table,
Okay,
and
it's
we will do.
easy to understand, but
Yes,
it's
can you
like
speak loudly? Actually, I'm not getting voice properly. I'm getting a slow voice, please. You
I
can
was
speak loudly.
just saying that it's easy in theory, but it's actually
Practically, you are looking for.
in
Practically, you are looking for, my dear. You want to see the practical of such thing? Am I saying?
yes, sir, but it's fine. But it's fine if we do it after the midterm.
Oh, okay, okay. My dear, just I want to tell you, we will understand the concept of the normalization next week with the theoretical way, and after the midterm, I will try my level best to explain all the normalization with the practical way. Okay, no problem, we will do. And now keep in mind, I will tell max to max second or third normal form, because we are looking for the table for the BCNF and PZNF and fourth NF. So definitely it will takes much complexity, because at the time I need the huge database. So but for showing to all this concept, I will tell you, I will explain you. Okay, no problem. After the midterm, I will tell you with the help of the practical way. There is no issue. Okay, so the theoretical is necessary. Okay, so theoretically necessary to understand. Now, if you're not aware about the functional dependency, you are not aware about decomposition, then how you can say? So this is necessary part. Okay. Now, shall I continue to explain this concept?
Yes, sir.
Okay, so now we have another relation. Now consider the following relation. Now what are the entity we have over here? We have the another relation. We have that is the this table. In this student relation table, we have also roll number. We have the name. We have the department. We have the year of the student, and what is the name of the hostel like Ganga, Kaveri, and Periya, and so on so on. Now roll number uniquely determine the name. Yes, please tell me. Is it correct? Roll number uniquely determine the name.
Yes, sir.
Yeah,
Correct.
okay. Okay. So Rohit could be many times, but each and every Rohit associated by roll number determined that he or he is a unique Rohit. So this is the point. Now say roll number uniquely determine the department. Can I say roll number uniquely determine the department of the student?
Yes, sir.
Okay. So what's your name? Suppose I'm asking you. So what's your name?
Sir Shivam.
Shivam. Shivam Bajpayee. Okay. Shivam. Shivam Bajpayee name is also exists into the mechanic department and the AC department. But I am looking for the Shivam Bajpayee. Then I will found five Shivam from the our university. Then how I can say which Shivam to I need to talk. So it is better idea to I can need the information that is roll number. So if I have the roll number, so I can easily say this is my Shivam that I'm looking for. So department also associated. Then I can say his roll number, his name, his department, his year, and his thing, each and everything I have. So according to our university, the simple idea we have the first two digits belong to the year, so definitely we can easily identify if the year in hostel name is not given. So no issue. But department in our department, Shivam Bajpayee also belong to computer science, but there are the five Shivam Bajpayee who belong to the computer science department. Then how I can differentiate your information? You are the same Shivam Bajpayee or the Shivam Bajpayee to whom I need to look for. So roll number also distinguishes the part determined by the department, of course, followed by the name as well. The roll number also uniquely determine the year as well, like 19 BAI, 19 BC, and so and so, 20 BCY, 20 BCE, and so and so. Can we say roll number uniquely determine the hostel? Can we say roll number determine the hostel uniquely?
Yes, sir. If we have means associate the roll number with hostel, like this roll number is live in hostel or not.
Yes, of course. In the hostel, boys number, hostel number two, and there's a student who belongs to Shivam Bajpayee, but I'm just looking for the entire detail by the roll number, his roll number only. So, suppose I have the roll number 19 BCY 10043, something. This is a roll number. I don't know who is the student. I don't need the name and department and year, but I know only the roll number. And from this roll number, I can easily search out the detail. Here the student belong to the what is the uh, his or her hostel. Okay, boys number two, boys number one, or maybe she may be girl. So definitely the girls hostel. So I can easily find out the hostel name of the student. So roll number is my key attribute over here. From this point, I can easily determine. So you can see in this relation name, department, year, and hostel. These are the non-key attributes which are associated with the or which are depend on the roll number. Can I say?
Yes, sir. We can say.
So the second normal form is saying to us if you have any relation and in your relation you have the key attributes. Okay, you have the key attributes and that could be primary key like that or record or any information which determine the uniqueness. Then all non-key attributes are depend on the key attribute at the time you are looking for the second normal form. So now I'm moving to my next slide. So we can say this is the relation which is in the second normal form. So at the time we have, at the time practical, we have tried, or we have tried to create many relation, but we are providing any key. At the time we are not providing any key, just I am taking the student name, student age, and department. So at a time by default I am creating a table which is the part of the first normal form. But to provide a uniqueness, if I'm putting the student id as a primary key, so I'm doing the creating, I'm creating a table, create table name, and student id as a primary key, and other relation as other information will be as it is. So what I'm doing, I'm changing my first nf to the second normal form. So you are also belong to the second normal form, and the student asked me the question, say, can you show the practical? We have already done this kind of practical many times. First time we just try to create a table that is belong to the first normal form, and second normal form you have done the practical with the help of the applying the only the primary key. So by applying the primary key and each and every attribute, if each and every attribute depend on the our primary key attributes, so definitely what we are doing, we are following the second normal forms. Okay, so this is a part we have already done into the practical way as well. Okay, so this is the part. Now see, student name is depend on the student name is depend on the student id. So this is what, this is the good point. So we can say, and student course, that is cs 301, and something like 3001 something, it is depend on the core roll number, if it is depend on the course. So we can say the student name and student uh, course which is opted by the student is depend on the his or her id. So we can say that these three different attributes, or the relation which is having by the these three different attributes, are belong to the second normal form. So now at a time you have to use what the parameter, what the attributes are depend on the other attributes. So at a time that you have to keep in mind the important term that is known as the non-key parameters are depend on the key attributes. So we can say that our relation will be by default will be in form of the second normal form, and first or initial normal form is known as the first normal form. So this is the point. So second normal form and first normal form are simple to understand, but we are looking for the third normal form, so it takes much time to understand. So that's why for today only we are looking for the second normal form and first normal form. So can we say this is the second normal form? Yes, we can say, because name, department, year, and also each and everything it depend on the roll number. Now you can take any real example like your Aadhaar card number. So your name is depend on the your Aadhaar card number. Your address is depend on the Aadhaar card number, and your biometric details are depend on the Aadhaar card number. So we can say, so Aadhaar card number is a primary key. So all the details which are keeping into the Aadhaar card number, your name, your address, your biometric details, definitely by default this relation belong to the second normal form. So we can say, of course. So this is a simple example. Yes, please. Now tell me, this is clear to you right now?
Yes, sir.
Okay. So now see, I'm just showing to my pictures to explain the concept what I spoke over here. Non-key attributes. Okay. Name, department, year, hostel, and what is the key attribute? Roll number. See, these are the functionally determined. Okay. Now functionally determined. So dependency exists between the year and hostel. Of course, it is also possible. So hostel is depend on the years in which hostel number the student have, which is year student has to move. Okay, in the boys hostel number one, only the senior student will be there. In the boys hostel number two and three, only the junior student will be there. So hostel detail, hostel name will be associated with the year. So definitely we can say we can make the functional dependency. It is also possible. So dependency we can like this one. Roll number is a key attributes. Name, department, year, hostel are the non-key attributes. Okay. So this is the point. So redundancy of data we have like here. So of course we have. So there will be the insertion, update, and delete anomaly. So of course there will be this anomaly. So to avoid such anomaly, we need to move to the third normal form. Okay, so third normal form is coming or is required when you have the anomaly. And what is the anomaly? Insertion, updation, and deletion. So entire record there is no duplicacy, but when talking over the dependency, then there will be the duplicacy is available here. So to avoid the such duplicacy, we need to understand the concept of the third normal form. So before jumping the normal form, just let me know over here. So far we have seen the this part. Is it clear to you all right now about the second normal form?